values that the spectrum of A. Okay, now we have proposition. Let me more functionality analytic on and is entire and also the Louis theorem Lewis theorem. Let F be entire and bounded. Then the cover and such as X. We say F is called position by see the information okay will find another step we prove this following see in the following okay and we can follow this from our book. We know that this map is continuous and we know that the set of all invertible elements of A is open, okay? The continuity of this map is trivial let me write this for you. Proof let theta from C to A defined by theta of Z equal to Z A minus A. Okay, Z belong to complex numbers. Then for any Z and W in complex number, we see that theta of Z minus theta of W equal to this norm ZEA minus A minus WEA minus A, and this is equal to, because this 2A can be omitted, and this is equal to absolute value of Z minus W multiplied by the norm of EA. So theta is continuous. Okay, and also uniformly continuous for any epsilon. We have this delta. We consider delta equal to epsilon divided by this. Then we have this implication: if Z minus W is less than delta, then theta of Z minus theta of W is less than epsilon. Okay, because this less than delta and delta equal to this. Okay, this multiplied by this equal to epsilon. Okay, this theta is continuous, and you know that in any topological space, if X and Y are topological space and T from X to Y is a function, then the following statements are equal. Or equivalent. One, if X to Y is continuous, 2 for any open subset of X if U, for example, is an open set, then the inverse image of U in X is open, and also if F, for example, is a closed subset of Y, then the inverse image of F be a closed subset of X. Okay? These three statements are equal, and you know this proposition. Now we know that theta from C to A is a continuous map. Okay? Continuous function. Okay? And we know that this is an open subset of A, so that by this proposition the inverse image of A is an open subset of C. Okay? For any open subset of Y, the inverse image of this must be open. And since the invertible elements of A is open, its inverse, the inverse image of this set under this continuous function must be open. But let's see that the inverse image of this set or we can write Z belong to the inverse image of inverse A if and only if theta of Z belong to inverse A. Okay? And this holds if and only if, because this is the definition of theta of Z. Z is A minus A be invertible. And this holds if and only if Z belongs to row of A, resolving set of A. This is the definition of row of A. Okay? Z belongs to this if and only if this be an invertible element. Dear student, sorry, I'm very sorry. I'm very sorry. You don't see any image. Let me write.
ألم يكن لديك صورة من بداية الفصل؟
Let A be a unit of Banach algebra and A belong to A. We want to prove these 5 statements. Okay. For this, I recall is the complement of row of A and the spectral radius, and the resolvent function of A is this function from resolvent set of A to the invertible elements of A. Then we see this equality, and also we define the spectral radius of A. Spectral radius of A, okay? And also I recall some notations and theorem for you. This definition. A complex valued function that is analytic or homomorphic on the whole complex plan is called entire function. Okay, if a function is analytic on all complex numbers, we say this is entire. And we have Liouville's theorem. Let f be entire and bounded, then f is a constant function. Okay, we use the Liouville's theorem in the proof of our proposition. I recall this for you. And also we have this definition. Let f be a function from an open subset of G into a Banach space X. F is called analytic whenever for any lambda in the dual of X, these functions Z maps to lambda of f of Z, or lambda of f. The composition of lambda and f is analytic for each lambda. Please note that this function is a function from complex number to complex number. Okay, and in the following we see resolvent function is analytic in our proposition. Please note that this f is a function from G to a complex number such as X, and lambda, this is our f, and lambda is a function from lambda to c, because this is in our dual. And let I write this G is a subset of C itself. G is a subset of complex numbers. So that lambda OF lambda OF is a function from C to C, okay? This is lambda OF. Okay? And this analytic is the ordinary definition of analytic function. In this proposition, we see that resultant function is an analytic function. Before proving this proposition, I recall some definition that you see this, okay? Dear students, now we can begin this proposition. Let A be a unit album of algebra and A belong to A. The part 1 say that the resultant set row of A is open in complex numbers. Proof: let theta from C to A defined by this row theta of 1 to ZEA minus A for any Z in C complex number. Then for any Z and W in C, we see that the norm of theta Z minus theta W equal to the norm of Z EA minus A minus W EA minus A, and we can omit this to A. Is equal to this. So this theta is 3, and this is uniformly continuous, because for any epsilon, if we consider this delta, epsilon divided by the norm of E, then we see this implication. If Z minus W is less than delta, then the norm of theta Z minus theta of W is less than epsilon. So that this theta is a continuous function. But we know that this is an open subset of A. So The inverse image of this set is open in complex numbers. Since this inverse image equal to row of A, the proof is complete. Okay? You know that in any continuous function, the inverse image of any open set must be open. I write this for you. If t from x to y is continuous, then for any open subset of y, the inverse image of this under t must be open, and also the inverse image of any closed set must be closed. These three statements are equivalent, okay? If x and y are topological spaces and t from x to y is a function, then the following are equivalent. T is continuous, the inverse image of any open set is open, and the inverse image of any closed set is closed. Now we know that theta is a continuous function. We see this, and we know that the inverse elements of A is an open subset of A. So the inverse image of this open set under this continuous function must be open. But this inverse image equal to resolvent set of A, because if Z belongs to this inverse image, Z of theta of Z must be belong to the inverse image of A. By the definition of theta, because we define theta by this function rules, okay? ZEA minus A. So that ZEA minus A must be invertible. So that Z must be belong to the resolvent set of A. So that this holds easily, and the proof is complete. Two, for each lambda in A prime is the dual of A. You can denote the dual of A by A prime or A star, okay? The function lambda O RA is the resolvent function, is analytic on row of A, is analytic. For this, let me write this for you. For each lambda in A prime or A star, lambda O RA is an analytic function on row of A. Now this proof is easy because if we fix Z in row of A, resolvent set of A, and fix W in row of A minus Z, and consider F equal to lambda of RA, we see that F of W minus F of Z divided by W minus Z equal to lambda of this, because this is lambda of RA of W, this is lambda of RA of Z. Okay, let me write this for you. Lambda O RA. Okay, let F equal to lambda ORA and Z non equal W, then F of W minus F of Z, okay, divided by W minus Z equal to lambda of RA of W minus lambda of RA of Z divided by W minus Z, and this is equal to 1 divided by W minus Z multiplied by lambda of RA W minus RA Z, okay, because lambda is a linear function, so that because lambda is linear, you know that lambda considered in the dual of A, and also we know that we have this equality, so that this is equal to Z minus W, for example, Let me write indeed. Lambda of z minus w then these two must be let me write in this line lambda of and since lambda is linear again, this is equal to this multiplied by lambda, and so that this is equal to minus lambda since this is linear again. Okay, lambda is linear. We use this fact again. Minus lambda of so this limit exists okay, this limit exists and equal to minus lambda Ra z to the power of 2. Okay, this multiplied by this. Okay, and this shows that f is analytic and f is differentiable in any point of G. Okay, for this using 1 4 2. Okay, 1 4 2 that we see in this. No, 1 4 2 let me see this proposition. Okay, the inverse map is continuous. Okay, and we use this for the previous statement. The set of all invertible elements is open. Okay, so this F is analytic on row of A. Okay, dear students, we can continue the rest of this proposition in the next session because we have 3 parts, and we can continue in the next session. Dear students, do you have any questions? Okay.
أعتذر عن المشكلة التي تسببت في الصورة. أصدقائي الأعزاء، قد لا تعقد بعض الاجتماعات الأسبوع المقبل. سوف أدعك تعرف.
Okay. Okay. Thank you very much, dear students. The first part of this session. Thank you very much. And goodbye for now. Goodbye.